All right, howdy folks. Welcome back from spring break. We are going to get started on video notes today for inverse trig, starting with Arcsine. So this is your warm-up. Just let me know what you remember from the unit circle. We've got 6 equations here. Solve each of these for theta between 0 and 2 pi. We'll give you a minute to do these problems. Go ahead and pause the video right now. All right, welcome back. Here's some answers. Go ahead and check yourself. How did you do? All right, and then let's push forward to the meat of today. So using your calculator, that means your TI-84, go ahead and break out your TI-84. Hopefully you have charges at home. Hopefully you're staying fully charged. But using your calculator, we're going to solve each of these equations for theta between 0 degrees and 360 degrees. All right, so I'm going to go ahead and get my calculator up here. All right, handy dandy calculator. First thing we're going to do is make sure that we are in degrees. So I'm going to go to mode, scroll on down. Right now I'm in radians, but I want to be in degrees. So scroll on over, hit enter. We're in degrees, we're good to go. Go ahead and quit out of your menu. Right, and the equation that we were solving, to remind you, is sine of theta equal to 1/2. Sine of theta equal to 1/2. All right, the way that we're going to use our calculator to do this is we are going to take the inverse function, right? The inverse function of sine, which we call sine inverse or arcsine. So you're going to find that right above the normal sine button, but we're going to use the second to get there. So that blue sine inverse, we're going to hit second sine. And now up in our calculator, we have sine inverse waiting for an input for our arcsine function. So we wanted to solve when the ratio is 1/2. We are going to solve alpha y equals, you don't need to do the fancy fraction, but I like the fancy fraction. Why not be fancy? Right, so the inverse sine of 1/2, we hit enter, and sine is 30 degrees, right? Makes sense. We probably could have guessed that using sine of theta equal to 1/2, right? But if you were noticing, this is pretty much the same problem as what we did in the warm-up. In the warm-up, we had 2 answers. Right here, we only have 1. The calculator is only giving us 30 degrees. It's not giving us 150 degrees, which would be the other part of the solution to this equation, right? Why is that? Wonder about that. Let's do another, and then we'll come back to that. So our next equation was sine of theta is equal to -√3/2. So we're going to do the same thing. I'm actually just going to borrow the entry from before, and I will just change the 1 to a negative square root of 3. Hit enter. And now the calculator tells us that it's -60 degrees, which is true. The sine of -60 degrees does result in -√3/2. However, -60 degrees is not within the interval that we specified. We wanted theta to be between 0 and 360 degrees. -60 clearly isn't in that interval. So the question is, what's happening there? And how is, our understanding of trig equations influencing and not congealing, not coalescing with what it is that we're getting in our calculator. So for that, we're going to pop over to Desmos. So over in Desmos, I've got some equations all lined up. The first one that we're going to look at is y equals sine of x, right? Classic sine curve, we know it, we love it. Y equals sine of x. And in order to solve the equations that we had in our notes, right, what we were doing in the calculator was using the inverse function. Right, now that's different from the inverse meaning reciprocal, right? The reciprocal function is something entirely different. We know the reciprocal function is cosecant of x. Really, though, what we're talking about is inverse functions. So think back to the first semester where we flipped things over the line y equals x, where we did things like swap the variables and then solve for y, right? Really, the inverse function of y equals sine of x is x equals sine of y, and that looks like this. Right, now one of the things that you'll notice about that blue curve is that it's not a function, right? We're looking for an inverse function, but that blue curve doesn't pass the vertical line test, so it can't be a function. So in order to have something that's going to solve these equations, we're going to not use x equals sine of y, and instead use this function y equals arcsine of x, right? And y equals arcsine of x is a function because we reduce the range, or we restrict the range, but that means that we're only going from this point down here at -1 comma negative pi over 2, and we're going to stop over here at 1 comma pi over 2. All right, so let's get some of that in our notes. Let's head back to the notes. Back to the notes. All right. So this box just re-summarizes everything that we were talking about up above. The arcsine function, which you're going to see in two notations, so sine with a little inverse exponent, a little -1 exponent, or the word arcsine, right? It's a one-to-one function that serves as the inverse function of the function sine of x. So that's different from a reciprocal function because sine inverse of x is the same thing as arcsine of x, whereas if you take the entire inverse of the evaluated function sine of x, that's what results in 1 over sine of x, which we know to be cosecant of x, right? So there's a very big difference in this small bit of notation, and make sure that you're using that correctly. All right, let's talk about domain and range. So the domain is -1 to 1 inclusive. The range is negative pi over 2 to positive pi over 2 inclusive. Really what that means is that if we have a unit circle and we plug in any ratio into arcsine, right, to go from -1 to +1, right, for the y, quote, quote, equals sine value, we're going to get everything in quadrants 1 and quadrants 4, because that's where theta is between negative pi over 2 and pi over 2, right? So that's one of the big takeaways here, is that when you're using arcsine, you're only going to get angles back that are in quadrant 1 or quadrant 4. Right, so let's try that out in a few problems. Compare the solutions of the equation sine of theta is equal to √2 over 2 over the interval 0 to 2 pi. We can do that, right? We can draw our axes, same as we did back in unit 8. So we're going to pop up a unit circle, and sine of theta is equal to √2 over 2. That's going to happen here and there, come on, here and there on our unit circle, which means that we are looking for theta equal to pi over 4 and 3 pi over 4. Right, but when we talk about evaluating sine inverse of √2 over 2, remember that we're only looking in quadrants 1 and 2, which means that this is equal to just pi over 4. All right, let's try that again in a different way. So let's evaluate arcsine of -√3 over 2, right? Arcsine of -√3 over 2. So I can draw my axes. I know that for arcsine, I'm only looking in quadrant 1 or quadrant 4, but we want -√3 over 2 for our sine value. So -√3 over 2, about there, right? Knowing all of my values around the unit circle, I know that what we call the principal value, right? The principal value, just meaning the output of an arcsine function, right? The principal value is going to be negative pi over 3, because the reference angle here is pi over 3, and we want the negative angle that, again, is in the range of negative pi over 2 to pi over 2. Right, so arcsine of -√3 over 2 is equal to negative pi over 3. Right, question is then, how can we use that? Well, how can we use that to solve our equation? Sine of theta is equal to -√3 over 2. right? So if we know that -5/3 is one of our angles and that we're looking for everything with the same y value, the same sine value, then using our reference angles, we can see that this is 4π/3 and 5π/3. So our solution set is θ equals 4π/3, 5π/3. Right, that's the essence of today. Can you solve sine equations for theta, and can you evaluate arcsine expressions, right? And can you differentiate between each of those two when you're asked to do so? So there are 6 bonus problems. Oh, can't count. There are 8 bonus problems down here. You're welcome to do them if you have time. I'll pop up answers in just about a few seconds. But otherwise, I will see you back in class where we are going to get into groups and do a Go formative. So just give me a moment and I'll get the answers up. All right, Shablam, here are your 8 answers. Feel free to shoot me any questions if you got them. Otherwise, see y'all later. Have a good one.